Boom. Alright guys, now let's continue with alcohol conversion. Alright, for chloroalkane, let's say if you want to convert to a chloroalkane, right? We can also use a PCl5. So using a PCl5, we can use it under room temperature. That's it. Okay. So guys, the equation is gonna be, let's say if I have a C2H5OH, I add a PCl5, it's gonna be a C2H5Cl plus a POCl3 plus a HCl. That's it. All right, that's the equation, yeah, guys. Please write it down. All right, guys, next. Let's look at PCl3. All right, guys, we can also use a PCl3, okay, to halogenate an alcohol. So if you use a PCl3, remember you have to heat it. Yeah? So this reaction requires heating. Highlight PCl3, highlight does require heating. Oh, bro, a bit insane, yeah. Okay, all good. All right, guys, next, what we have is a bromoalkane and iodoalkane. So, guys, if you want to get a bromoalkane or iodoalkane, okay, what we can do, we can always put a Pi3 or PBr3. That's it. Yes, you have to memorize the equation. Guys, the equation you have to memorize. There's no escaping from the equation. Unfortunately, you have to memorize. Okay? All right, guys, now, let me show you for reaction with a PCl3. All right, guys, at the same time, let's say if you want to, okay, if you want to get a C2H5OH, if I want to halogenate it with a PCl3, what it's going to turn into is going to turn into a C2H5Cl plus a H3PO3. Please balance the equation. Give me a second. I'm sending it to you right now. Yeah. All right, guys. Reaction with PCl5, right, is usually and commonly used to test for the presence of alcohol. Yeah. If you use a PCl5, all right, guys, you see, using a PCl5, you get a HCl is formed. When a HCl is formed, yeah, this HCl is released as a steamy white film. Get me? So you get a steamy white film is formed. That's it. Okay, as a white film of HCl is given off. That's it. All good? All right, guys, now let's continue. All right, let's move on to RCl and RBr. All right, guys, again, let's say if you want to halogenate a chloroalkane, what we can use? If you want to halogenate into a chloroalkane, we can use a PCl5 or we can use a SOCl2. Okay, so these two, right, you can just throw it under room temperature will do. Okay, so these two reactions will just go on as usual, does not require any heating. Okay, but guys, let's say if you want to heat it, okay, then you can use a PCl3. So PCl3, remember, you have to do it with heating. Yeah. All right, guys, next. All right, kid, let's say, okay, if you want to, okay, in new syllabus, right now, the new syllabus, right, we can also use HCl. Okay, we can either use a HCl or KCl, yeah, with a concentrated H2SO4 or H3PO4. Okay, so this can also be, okay, we can also use this, yeah, to turn an alcohol into a halogenoalkane, especially a chloroalkane. That's it. Oh, good. Alright, guys, next. Let's say if you want to see a RBr, like for example, a bromoalkane. So to turn something into a bromoalkane, what we can use a PBr3 with heat. Okay, this is possible. Okay, guys, let's say if you don't want to use a PBr3, I can also use a HBr, yeah. Understand? Alright, guys, let's say if you use a HBr, right? Okay, so remember the HBr can be with a concentrated H3PO4. Clear? Alright, guys, next. If you want to get an I, can be Pi3 with heating, or also Hi with a concentrated H3PO4. That's it. Done. Next problem, this can be answered. What is your answer? What the hell are you?
不知道
我不知道。
simple 啦 this one
This one simple lah, easy lah.
HCl concentrated H3PO4
Oh, thank you very much. HCl concentrated H3PO4. Done. Alright, all good. Alright, next part. Let's continue. Alright, guys, next. A reaction with sodium metal. So in some reaction, OH bond will break. Okay, for example, react with a sodium metal. Let's say, right, if I have this alcohol, and I add a sodium metal. Alright, guys, what's gonna turn into? This Na is gonna replace the H here, yeah. So eventually it's gonna turn into an ONA. And a H2 is formed. So to balance the equation, 2, 2, 2 is needed. Wait, nothing one. My God, I just realized my screen. Bro, a second. Why never tell me? Bruh. Okay, there you go. Okay, O minus Na plus, guys. You see the hydrogen will be replaced by a sodium. Let's go. Done, yeah? Alright, guys, next. So I can say that, right? Okay, so the reaction is similar to sodium with water, okay, but less vigorous. In both cases, hydrogen gas is given off now. Done. Understand? Okay, next. Okay, what we have next, right, is esterification. Yeah. Guys, for esterification, it's a reaction with alcohol and carboxylic acid. Yeah. Okay, so for this reaction to take place, right, your carboxylic acid and alcohol are heated under reflux. Remember that. you must heat it under reflux, yeah. Okay, with a concentrated H2SO4 as a catalyst. Highlight the word heat under reflux. Highlight the word concentrated H2SO4 as catalyst. That's it. And guys, for the ester form, right, usually will have a fruity smell, yeah. Alright guys, now let me show you your esterification reaction. Okay, looking at your A-level content, right? So I'm gonna make it harder, yeah. You guys already done it in IGCSE. Okay, for example, I have a ethanol acid, and I'm gonna react it with this thingy. And alcohol. Okay, guys. I want you guys to draw a skeletal. Try your best to do it in skeletal, okay? Guys, again, when esterification reaction happens, okay, what you are removing, remember this. We are removing OH from your carboxylic acid, okay, and H from alcohol. Then we try to join them up. One more time. We try to join them up like that. C double bond O, join here, then join with the entire thing. Get me? Okay, one more time. C double bond O, join with the entire thing. Alright, guys, can you guys try to draw it out? Can? Go. Okay, guys. So what's gonna turn into? Okay, so kid, if you're not so sure how to do it, I'll show you. So my double bond O is there, but I remove my O, yeah. Okay, so the OH is removed now. And kid, let's connect it to a O here, yeah. So I'm gonna connect this to O and O. And guys, if you're not so sure what to do, right, you can always put number. So again, you can always put number around your carbon. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So as you can see, this O is connected to the carbon 2, then you can draw 3, 4, 5. So I can connect to a carbon 2, 3, 4, 5. Can see. One more time, 2, 3, 4, 5. Then I have to connect to another one, which is a carbon 1. So can see that? Now I completed my 1, 2, 3, 4, 5. There is another link on the second carbon. You have to draw another link on your second carbon. That's it. That is my ester. Understand? And the H2O is formed. Clear? Please write it down. And once done, alright guys, I want you guys to look at the next part. So for ester naming, remember the first part of the name always come from alcohol. The second part of the name come from a carboxylic acid. And guys, please fill it up. Go, go. Give me a minute. Alright guys, next, propan metanoate is gonna be HCO, then O, C3H7. Last one, butanoate, C3H7CO, then O, C2H5. Done. Understand, yeah? Alright guys, please write it down. Once done, we are moving on to the top part. Alright guys, let's say right, if I were to give you a cyclic ester, I want you guys to try to draw a cyclic ester. So for example, I have this. Oh, this is a bit harder, guys. Alright, guys, can you try to draw the ester here? This is a bit hard. Let's try. Guys, know how to draw? This is slightly harder. Actually, kind of difficult also. You will get a cyclic compound, which means everything is gonna be an enclosed one, yeah. Wait, I don't understand the chemical formula part. So the chemical formula always carboxylic acid go first. Understand? So butanoic acid has 4 carbon, right? Which means C3H7CO. It does something like that, what? CH3, CH2, CH2, C double bond O. That's your butanoate, right? Then connect to ethanol, C2H5. That's it. Understand? Alright, guys, now, again, to draw the ester, this is a bit hard, yeah? So, guys, I will slow down. First, we have to circle the part that we are removing, the OH we are removing, right? Circle the OH. Next, we are removing H here, and we are removing H here, correct or not? Okay, then guys, I know that this C double bond O is going to join with one of the O here. Then another double bond O is going to join with one of the O on another side. Clear? So what you're going to do, you're going to draw a ring that join them up together. So guys, first I can draw this out. You see, I can start counting the carbon number 1, 2, 3, 4. So what I'm going to do, okay, I will start drawing 4 carbon first. 1, 2, 3, 4. Double bond O, double bond O. Correct or not? 1, 2, 3, 4. 1, 2, 3, 4. That's it. Okay, all good. Alright, guys. After that, once done with this, the next part is to join here. So, guys, I'm going to put number as well. So, you see, right? 1, 2, 3, 4. Maybe this will join to the O of the second carbon. Okay, so maybe I will join it here. Okay, so join here, then to 2. So I can join it to 1O. Then this is going to be the second one. So I have to draw a tree. Okay, 2, 3, and join back to an O. Correct or not? Oh my god, a bit ugly, but yeah. It does look something like that. I see that. So one more time, you see? O join here to a 2, then to a 3, then O. 2, 3, O. So what is missing? The 1 and 4, right? So add here, add here. So now you see 1, 2, 3, 4 completed. This is your diester. And 2H2O is formed. Clear? A bit harder, yeah, guys, this one. Okay, please try to draw. Any question? All good, yeah. Alright, guys, please write it down. Once done, we are moving on. Okay, once done. Okay, kid, let's go. Alright, guys, next what we have is a hydrolysis of ester. So, guys, what is hydrolysis, right? Right now, what we are doing, we are breaking down of ester. So, when you see the word hydrolysis, okay, we are breaking down. Remember, breaking down. Okay, let's break down your C11O. And guys, where are we breaking? It's always in between your ester linkage. C double bond OO, in between them, this is where we are breaking. Alright guys, next. Ester can be hydrolyzed by heating under reflux with either acid or alkaline. So guys, if you reflux it with an acid, Okay, it simply reverse the preparation and you are getting a carboxylic acid and alcohol. All right, so guys, in acid hydrolysis, okay, they are always both reactant. Yeah, you get ester plus water. Okay, then your product is always a carboxylic acid plus alcohol. Okay, so acid hydrolysis, you are getting carboxylic acid plus alcohol. That's it. All right, guys, nice. Let's look at this. All right, guys, I want you guys to try to hydrolyze this for me. Go. So, guys, in acid hydrolysis, right? The reaction is always reversible, yeah. Okay, so reaction is always reversible here. Okay, guys, try to break it down. So always remember, right, when you are breaking down your ester, you are breaking a C double bond OO, yeah. So this is where we are breaking. You see your C double bond OO? Can see that that's your ester linkage. We are trying to, okay, dismantle this part. Okay, go. Okay, no, it will not turn. Oh, yeah, that is just a ketone. You are right. The ketone is not going to do anything, yeah. Okay, done. All right, guys, what do you got? So when you break this part, kid, let's go. So the first part, yeah, whenever you see a double bond O, right, it's gonna turn into a carboxylic acid. So I just have to draw a carboxylic acid around. You get the OH here, understand? Then the remaining part is just gonna turn into an alcohol, understand? So just add a H, done. Clear? Know how to draw. Easy, right? Not too bad, yeah. So remember, it's always reversible, yeah. Clear. Alright, guys, nice. However, in alkaline hydrolysis, okay, you are getting something else. So for alkaline hydrolysis, what we can use NaOH, or we can use the KOH. And guys, for alkaline hydrolysis, the product is always a salt, COONA, okay, and high and alcohol. So you get a salt and alcohol as your final product, yeah. Understand? Okay, guys, now I'll get you another cute looking. Okay, let's go. Okay, that's it. All right, guys, please hydrolyze this ester for me. Let's go. Okay, when you are hydrolyzing it with a base, the reaction is just one directional, yeah. What's the method to memorize organic reaction? The method to memorize is just to do more past paper. The more past paper you do, the better you get lah. Okay, try to hydrolyze it, guys. Remember to break down your ester linkage. The goal is to break down your ester linkage, okay? Once you're done breaking your ester linkage, your answer should be quite obvious already. You get a single product, guys. Let me check on your answer.
Single product.
Yeah. 哎呦，我有出啊。Oh. Single product.
Oh, single product.
A single product. Guys, if you're not so sure how to do it, put a number around your rate. Once you have a number around your rate, it's gonna be easier to do it. So, Emma. Alright, guys, this one is a bit harder, yeah. Okay, now let me show you how to do it. Okay, first thing is, if you are stuck, right, every time you're looking at this cyclic compound, my advice to you is always to put down a number. So I know that this is where we are breaking a C double bond OO, correct or not? You have to break this part. So put a number, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. Correct or not? So basically, you have a 7 carbon that is linking together. So we're going to draw 7 carbon. Let's go. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. That's it. Let's see how. Okay, I'm going to put down the number again. 1, 2, 3, 4, 5, 6, 7. Clear? So guys, carbon number 1 will turn into what? O and A. Get me? So I'm just going to put down O and A. Done. Then guys, carbon number 7, this one will turn into an alcohol. All right. That's it. Understand? Alright guys, remaining part, you just have to put the cockroach leg, right? Cockroach leg on 2, cockroach leg on 3, cockroach leg 2, cockroach leg 3, 4, there's a Cl, 4, there's a Cl, 5, 6, there's a leg, 7, there's a leg. Hey, wait, 5, no leg, 6, 7. That's it. How, 5 not? Does Cl get substituted? No, Cl is not being substituted by OH. I mean, technically saying Cl can be substituted by OH because you NaOH in. Yeah, your Cl can be substituted by OH. But okay, if that's the case, I don't want to confuse you guys. Just put it without the Cl. Just do it like that. But Alexandra, you got it right. Cl will get substituted by OH because of the condition. You are not wrong. Hi guys, please draw it out. Dana, clear everyone? Oh good. Okay, now let's move on. Guys, right now let's move on to dehydration, Kate. So for dehydration, what are we removing? We are removing a small molecule of H2O. Water is removed. Okay, and an alkene is produced here. Okay, since we are removing a small molecule of water, so this is also known as a dehydration reaction. Okay, so the reaction that takes place, we have to pass it to a hot catalyst of alumina, which is Al2O3. Huh? Bro, my screen froze again. Give me a second. I can see now. Guys, copy first. Alright, guys, next. So again, you can pass it to a hot concentrated alumina. Hot alumina or hot silica also can. Silica formula SiO2. Or guys, if you don't want to pass it to a silica, you can also pass it to a concentrated H2SO4. That's it. Done. Alright guys, nice. Alright, kid, let's say right, if I have an alkene that looks something like that, sorry, if I have an alcohol that looks something like this, alright guys, and I'm trying to dehydrate it with a concentrated H2SO4. Is H2SO4 for both alumina or silica? Oh, Brett got it right just now. Oh, thank you so much, Brett. I just saw your chat. Okay, yes, H2SO4 is one of it. Okay, or Hassan, you have three different reagent. Okay, any three also can eliminate. So this time I'm gonna use a concentrated H2SO4. Alright guys, let's go. So what you get, right, peeps? Okay, again, if you're eliminating it, we can eliminate OH here. And I can eliminate another hydrogen here, yeah. Can be, if I eliminate OH and hydrogen, my double bond position is gonna be here now. Walao eh. Why? What's wrong?
Much firework.
Too much firework, bro. My screen is lagging, bro. That's it. Let's see, guys, one more time. I can remove OH here and a H here. I remove these two, double bond position is here. Clear. Go. Second one. Alright, guys, where else we can remove? Alright, guys. Next, what we have is oxidation, yeah. Alright, guys, for oxidation, right? Your alcohol, okay, whenever you look at oxidation, okay, in organic chemistry, remember this, oxidation, right, is defined as gain oxygen and losing hydrogen, remember. Okay, this is what it means by oxidation, gain oxygen, losing hydrogen. That's it. Okay, please write down. So guys, how can we oxidize alcohol? We can oxidize by using a K2Cr2O7 or a KMNO4, right? Acidified under H2SO4. That's it. Alright guys, next. So if you use a dichromate, an orange dichromate, it's gonna turn green, yeah. And the solution turns green. And guys, the reaction mixture has to be heated first, yeah. Right now, heat. You need to know the difference between a reflux and distill. Okay, guys, what is a reflux, right? So for reflux, we call it as heating it completely, yeah. Okay, heat until like everything turns into a product. Okay, so what is a reflux? For example, right, you see if you heat alcohol, a volatile liquid, so alcohol is going to turn into a gas. Then you put a condenser to condense it back, then turn into liquid, then you heat it again. So alcohol is constantly turning into vapor, then go back, then hit again, then go back, hit again, go back, hit again, go back. So this we call it as a reflux. Yeah. Okay. And guys, substance is boiled and condensed continuously. Purpose of us is to get a carboxylic acid. Clear? Alright guys, what about this still? Okay, if you are oxidizing it under this still, so the reaction, right, is gonna turn into, you set the temperature, you hit it, for example, like 85 degree. So you hit it until 85, then you condense it and collect the product here. So for this still, it's always to obtain aldehyde. That's it. Alright, the product formed when alcohol is oxidized can be used to distinguish between primary, secondary, and tertiary. And guys, with a tertiary alcohol, no reaction take place. Remember this, tertiary alcohol can never be oxidized. Secondary alcohol, we will get a ketone. That's it. Okay, please write it down. Alright guys, now let me show you some example. Alright guys, let's oxidize this. Yeah. Alright guys, when you're oxidizing a secondary alcohol, remember this, yeah? Okay, oxidation is adding oxygen, removing hydrogen. So you see you have OH and a H here. What we are doing, we remove one hydrogen, two hydrogen. So you remove two hydrogen here, okay, and this thingy is gonna turn into a double bond O now. And see, one hydrogen remove, and turns into a double bond O. And next, this is also a secondary alcohol. Remove H, remove H. Okay, oxidation is removing H. So this part also the same. You remove two more hydrogen and it's also turning into a ketone. So you see, in total you have 4H, and this 4H is going to turn into a H2O. So eventually you get 2H2O. So balance the equation by putting a 2 here. Done. That's how you construct your equation, yeah, guys. All good. Is it like a cycle? What do you mean by like a cycle? Are we almost done with organic chem? It's almost. Not done yet, but almost. Okay, guys. Okay. All good. For like a reflux. Yes, correct. Like the reflux is a cycle. You are right. Estelle. Correct. All right, guys. Next, for primary alcohol, yeah. Okay, so you can oxidize it and immediately distill off to get an aldehyde. Yeah. So, guys, I will show you one example. Hey, oh my God, why is it lagging again? Go insane, brother. Alright guys, now let's say if I put it under oxidation, I want guys to draw it smaller. Okay, and I put it under distillation with KMNO4. Okay. Alright guys, draw it out. Ketone OH in the middle chain. Aldehyde is, yes, correct, you are right. Ketone is double bond O in the middle. Aldehyde is double bond O at the end. Alright guys, now the same thing here. You see? I remove one H, then turn into a double bond O. Get me? The same thing here. Remove one H, turn into a double bond O. So this thingy is gonna turn into a aldehyde. Get me? Okay, and you have two H2O here, guys. And guys, this is an aldehyde. Yeah? Alright guys, when an aldehyde is formed, aldehyde can be oxidized further. Let's say if I oxidize this under acidified and reflux with KMNO4, okay, it's gonna turn into a carboxylic acid. So if I oxidize it again, you see, this can turn into a carboxylic acid. Okay, so how does it look like, right, guys? Okay, just wait, see. By right, this part is a C double bond O and a H, correct or not? C double bond O and a H. What I'm gonna do, I'm adding one H in between the O. So previously it was like that, right? So I add one O in between the H. So it's gonna turn into a carboxylic acid. That's it. So the final product it's a carboxylic acid. Understand or not? Let's go. Which first part, the girl? Okay, the aldehyde, right, you see? OH, H, correct or not? So I remove one H, So you have two HO. So the H will combine with the O, turn to H2O. Then this will turn into a double bond O. Can. Okay, can be KMNO4 or K2Cr2O7. Can be both. Right. KMNO4 or K2Cr2O7 also can. Alright guys, draw it out. Ethanol, then carboxylic acid. No, it won't. No, it will not turn into CO2 and H2O. Alright guys, let's say if you want to oxidize from a primary alcohol straight to a final product, right? If you want to go this way, must be under reflux and acidified KMNO4 or K2Cr2O7. That's it. Okay, so a primary alcohol can be converted into a carboxylic acid straight by adding concentrated H2SO4, acidified H2KMnO4 and reflux. But the CO2H2O, that is alkene now. Understand, huh? Alright, next. The ethanol from can be further oxidized to form a carboxylic acid. Which is an ethanoic acid. This can be achieved by refluxing, okay, with excess K2Cr2O7 or KMnO4, yeah. That's it. Okay, guys, now I want you guys to try oxidize this compound. Please try oxidizing this compound for me.
Kayu nasi kandar is here.
Kayu nasi kandar. Oh, yo. Alright, guys, let's go. This is damn gay. Okay, I want you guys to heat it under reflux, which means a carboxylic acid is the final product. Yeah. Let's go. If you get this right, I'm proud. If you get this right, means you really understand everything inside out. Go. Hey guys, draw answer. Let's go. Come.
Wow, when you draw all this,
Walao eh. Anyone want to volunteer answer? Come. Walao eh. Very fun, right? Guys, FYI, I'm making this very difficult for you guys. So when you're doing the past paper, it's gonna be easier. Okay, thank you, Alex. Okay, Alex answer is perfect. Well done, thank you, Alex. Oh my god. Wow, I like you, Alex. Really, well done. Okay, I have one correct answer from Alex. Anyone? Someone? Okay, thank you, Brad. Brad answer is perfect also. Thank you, Brad. I think that's why it's Sunung already, right? Hidden top of the page, can? Alright, guys, I have two perfect answer coming in. I'm proud. I'm actually proud. Well done. Slightly downwards, can? I see. Alright, guys, let's go. Alright, first, you have to identify what type of alcohol it is. So for a secondary alcohol, this is a secondary, right? Will turn into a ketone. I can draw a ketone. Carbon bond O. Nice. This is a tertiary alcohol. Alright, guys. Okay, let me challenge you guys by guessing how many mole of water you will be getting. Okay, so let's see how many mole of H2O. So you see, right, originally there's 1H, 2H is being removed. I put a 2H here. Okay, that OH is a tertiary. You don't do anything because tertiary cannot be oxidized. Just leave it like that. Alright, guys, this is a primary. Correct. Primary is going to turn into a carboxylic acid. So put a double bond O and OH. So originally, right, it was like 2H, correct or not? You remove these two H's, add a double bond O, so 2H. Okay, done. Let's continue. This is the secondary. Remove one H, remove one H. Two H's also. Ketone. Correct. Okay, guys, this is a tertiary. Can see that, right? It's bonded to 1C, 2C, 3C. It's a tertiary, cannot be oxidized. Leave it like that. And guys, this is a primary. Can see that C bonded to just 1C, two H's. So I remove these two H's and turn it into a double bond O, OH. That's your final answer. Okay, so guys, how many mole? 1, 2, 3, 4. You get 4 H2O because you need to balance the hydrogen. Alright, guys, after that, you can balance your oxygen already. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 4, 12. This one at 1, 2, 3, 4, 5, 6. Okay, so 6. Then you have to put 6O to balance it. Done. That's how you balance the entire equation. Clear? Fun or not? How's your dinosaur looking compound? Guys, FYI, organic chemistry, we are 90%. Next week is going to be our last class doing organic chemistry. And we're done with it. Analytical not yet, but it's that easy. Don't worry. We are done with the hard stuff already. Alkene. Organic is alkene. Alkene is the hardest. Oh my god, look at my boy here raging over food. Isn't it chapter 15? Yeah, this is okay, right? Not too bad, right? Okay, guys, now I'm gonna give you my final study tips. Okay, to summarize everything, if I have a primary alcohol, if you oxidize under distill, so you'll be getting an aldehyde. Remember that, yeah? If you oxidize it again under reflux, you'll be getting a carboxylic acid. Clear? Or guys, if you want to turn an alcohol straight to a carboxylic acid, can also. You can do it straight also by oxidizing it under KMnO4 or K2Cr2O7 H plus reflux. That's it.
Oh shit.
Boy. Alright guys, for secondary alcohol, it's different story now. Secondary alcohol, if you oxidize it, it's gonna turn into a ketone.
The screen is frozen.
Yes, baby.
Yeah, the screen is frozen.
Wait, someone talking to me. Who? Alright guys, finally, tertiary alcohol. If you oxidize it, unfortunately can never be oxidized.
Aiyo.
Ayo.
Later lah.
It's okay lah, just drink all the curry. Then you will smell like a nun. Let's go.
Nice.
Oh. Yeah, the screen is frozen, teacher.
Hey, my screen is frozen. Shit.
Yeah.
Sorry. Oh my god. GG, sorry. No wonder. Okay, can guys copy this down? We are almost done already. Shit, all good. Okay, okay, guys, always remember, right, in oxidation, oxidation is always gain oxygen and remove hydrogen, yeah. Remember this, gain oxygen, remove hydrogen. Reduction, on the other hand, gain hydrogen, remove oxygen. That's it. Clear? Okay, guys. Now, the last part, we have iodoform test. Oh my God. Okay, guys, this one, your iodoform test is damn important, man. Like, very, very important. I want you guys to put a lot of stars here. It's very important. Okay, guys, for iodoform test, alcohol can be heated with aqueous NaOH and I2, or sometimes they put it as I2 in alkaline. Okay, they carry the same meaning. Okay, aqueous NaOH and I2, or I2 in alkaline. Okay, and you will get a yellow crystal of triiodomethane, which is a CHI3. Okay, you get a triiodomethane CHI3. Alright, guys, this I will draw a structure first because I scared if I draw a skeleton, you guys cannot picture it because you really have to picture it first. Okay, before getting good at it. Alright, guys, now let's go. Okay, so for a triiodomethane to form, you must have a CH3. I want you guys to circle this CH3. You must have this CH3 again, CH3 next to a COH. One more time, a CH3 must be present next to a COH. Okay, this is a must. Okay, and the reagent is going to be NaOH and I2. Okay, please copy this down. Okay, so you must have a COH next to a, okay, so you must have a CH3 next to a COH, guys. Ketone can. Yes, you also have a ketone. Yes, can be, okay, we can also use it for methyl ketone. But methyl ketone, we're going to do it next chapter. Okay. So guys, what you're going to do, okay, you have to break this part completely. When you break this part completely, this entire thingy is going to turn into a carboxylate ion. So how does it look like? It's going to look something like that now. You get a C double bond O and an O and A. Okay, so this entire thing will break up, and the CH3 will turn into a CHI3. Get me? Then you have NaI and H2O. Oh, good. 5, 4, 5, 1, 6 NaOH. And that's how we balance it. Done. 5H2. Okay, guys, remember, yeah? Okay, so you must have a CH3 next to a COH. Hassan, if there's no CH3 next to COH, this reaction cannot proceed. Bye-bye. Alright, guys, next. The reaction is commonly used to test for the presence of a CH3 group next to, I want you guys to write it down. Okay, we use it to test for the presence of a CH3 group methyl group, okay, next to either an alcohol or a ketone, aldehyde. Alright guys, now, again, my study tip is right. For this reaction, okay, we use this to test for the presence of, where do I put pencil? Ui. Apple Pencil cannot connect one. Wait, what? Oh, it was working fine. What the? Candy. Alright, guys. Okay, we use it to test for, remember, yeah, the presence of a CH3 next to a COH or a carbonyl group. Okay, that's it. And guys, the second thing is right, this test, we only and only test for a CH3. Get me or not? Okay, for example, guys, if there's a C2H5 next to it, cannot. If there's a C3H7 next to it, also cannot. Okay, so specifically testing for a CH3. Any other cannot. Okay, please. Okay, please write it down. Alright, guys, finally, remember this. A tertiary alcohol, yeah, can never give a positive result. Okay, a tertiary alcohol will not give a positive result. Wait, I have a chat coming in. Huh? Yes, methyl ketone, and yes, it can also undergo aldol form. Remember this, yeah? Okay. A tertiary can never show a positive result because tertiary alcohol cannot be oxidized. Done. Alright, guys, please write it down. Any question, ask me. Later, someone asked me to flip back to page 9, right? Can. Alright, you guys, write this down. And after that, try the question 1 to F, A to F. Please tell me which one can and which one cannot. Now. Alright, guys, let's go. Alright, guys, let's go. So first, butyl 1 can or not? Cannot lah. Why?
3 carbon next to them.
3 carbon next to a thing. Cannot lah. Cannot. No. Well done. Second, butan 2O can or not? Can ah? Can sure ah? 100% ah. Why? Have the methyl next to it, right? Well done. You not bad, boy. Nice. Good job. Okay, guys, next. 2-methyl pentan 2O. Can or no? Can ah? Have the methyl next to it. The answer is no. Don't want to tell you.
Oh, 2 carbon.
Okay, guys, this one, yes, I know that you guys, okay, tell me that, hey, there is a CH3 next to it. You are right. But what is this alcohol again? This alcohol is a tertiary. Remember, tertiary can never undergo, yes, tertiary can never undergo ionoform. Remember, please. Okay, nice. 3-methyl pentan 3. Cannot. Why? Tertiary also and no CH3, right? This is wrong in every way. Huiyo, understand? Okay, next. Propan 1 ol. Ayo, tak boleh lah, boss. Yes, tak boleh lah, boss. No CH3 next to it also. Cannot. Pentan 3 ol. Ayo, boss, boleh lah, boss. Cannot. Why you make me sound like a mama boy like that? No, cannot. Correct. So, guys,
We end class 30 minutes.
yes, we end class 30 minutes earlier. I need to go back and celebrate my C and Y. No, just kidding. Actually. Next week, only we do chapter 6, 17. Oh, do push-up. Oh, boy. Do handstand.
Cannot lah.
Push-up. Do pseudo push-up.
Walao, where's you?
Okay, so guys, that will be all for the class today. And I will see you guys next week.